Okay, so 4-3, we're going to get the first derivative test for local extrema. What are local extrema? What does that mean? Mins and max. Okay, so within this curve, say you had, something that did something like that, there's not an absolute maybe there, but there is a local max and there's a local min, and we're going to use derivatives to find those. You already know, if you had college algebra, you know how to find the max and min. There's several ways. You could throw it in the calculator, find the vertex that way, find the max or the min. You could use the vertex formula. You could put it in standard form if it's a quadratic. There's lots of things you could do, but now we're going to use the derivative to do that. Okay? All right. And then it talks about critical numbers, critical points, and those are found by taking the derivative and setting the derivative equal to 0. That's going to give you critical points. And then if the derivative changes from negative to positive at those critical points, that means it's going from negative to positive. What do you have? What do you have at the bottom? A min. If it goes from positive to negative, what are we going to have? A max. So that's how we're going to use the first derivative test. Now, this is kind of just a picture for looking. It says the critical points locate where the thing is increasing and decreasing. First derivative changes sign at a critical point. All right, now, if this is your graph, okay, f prime is equal to 0. You're going to have a horizontal line when f prime is equal to 0. Does that make sense? That's a horizontal tangent. Okay, so you can have it here. Now, there's no extrema here. So it's not, you're going to have to do a little bit of work when we do these. Here, there is a max because you're going from increasing to decreasing. So that means there's a max. Here, there's a min because you were coming from decrease and then increase. And you have a horizontal tangent there. What's wrong with this guy here? It's a cusp. It's a point. And so, since there's no curve, f prime is going to be undefined there. So if f prime's undefined, that could still be a critical number, but you're probably not going to have a max or a min there. I mean, well, you'll have a max, but the f prime is not equal to 0. That's what I meant to say. All right. So that's just to kind of look at that. So that's it for the notes. Let's actually work the problems. Okay. Let's see, we'll get these going. All right. If you don't have them in front of you, that may not be quite big enough. Let's see. Okay. I'm going to answer the following questions about these, and this will be important as you move into 4-4 and we get ready to sketch the curves by doing these derivatives. Some of this is what you're going to be doing. So let's get some room here and do some of this. All right, here's our function. F prime of x equals x. Okay. So this is actually the derivative. They're not giving you the regular function. What are the critical points? What did I say we had to do to find the critical points? Set it equal to 0. So if we have x times x plus 5 and we set it equal to 0, what does that mean? What are we going to have then? X equals 0, x equals negative 5. So those are the critical points. And I believe it asks for that in the first part right here, and it says use a comma to separate them. So you would put just 0, negative 5 there. And then it wants to know, where's this increasing, where is this decreasing? And this is how I like to do it. I have no idea what the book actually does. I just know what I like to do. So I draw a line, and however many critical points you have, you're going to put a hash mark for those. And you're going to put them in order left to right. Oh, good. It's always good. All right, x equals negative 5. X equals 0. Okay? So you're going to put that. And then we are going to pick a test value in here. Now, what's sometimes helpful, because you're going to be asked, where is it increasing? where's it decreasing? If we go ahead and define the intervals, then we've got that already set here. This interval would be from what to what? 0 to infinity. And this interval would be, and this one. Okay, so if you've done that, then that's where your answers are going to be for where is it increasing, where is it decreasing. So we're going to test these points in the first derivative. And remember, the first derivative was x times x plus 5, I think. That was f prime. All right, so we got to pick a test point. It doesn't matter what point you pick as long as it's in the interval. Okay, so if we did, I usually pick something really close to the barrier. So I did f prime of -6. I would do maybe f prime of -1 and maybe f prime of 1. Now, if you chose a different number, it's not going to matter. You're still going to get the same answer as me if your number's in the interval. Now, all we're worried about is the sign, S-I-G-N, of this. If I plug -6 in here, am I going to get positive or negative? Okay, think about it. You're going to have -6 times -6 plus 5. So it's negative times negative. You would get positive. Doesn't matter what value you get. You are looking for what's the sign. And don't think that it always alternates, because there will be a time when it won't. It often, most often does, but you need to check. So if -1 goes in there, what are we going to get? Negative. Okay? And 1, positive. Okay. So what I usually do is take, and I'm saying, okay, if this is positive, that means my function would be increasing, and at x equals -5 is where it changes, and then it comes down when it's decreasing. If it's negative, it's decreasing. Positive, it's increasing. Okay? If the first derivative is positive, that means the function is increasing. So I do that. Now on this one, we are decreasing here, and at x equals 0, we change and we increase. So what does that tell me about my original? What do I have in the original? You have a max here and a min here. Okay? Does that make sense? That kind of gives you a sketch of the curve, the original curve. Okay? Question, Mitchell? I mean, were you getting? Okay, all right. Any other questions? Okay, so let's go back up and see what it actually asked. It said, all right, it's increasing on the intervals. That means where's it positive? So these two intervals here, -∞ to -5 and 0 to infinity, would be right here. So -∞ to -5. Use a comma in between, and then 0 to infinity. That's where it's increasing. Positive in the derivative, increasing in the original. Where is it decreasing? Okay, it's decreasing from -5 to 0. Right here, because it's negative. Okay? Because it just said use a comma to separate answers. Typically, we would. All right, the function has a local max at x equals -5 goes here, and a local min at x equals 0. All right. That one didn't ask us the value of the max or min. If it does, where are we going to plug these numbers in? The original. The original. So if it says, you know, we just found where they occurred, but if it wants the value of the max or the value of the min, you got to plug it in the original. We'll be doing some of that. All right. Same idea on this one. And really, I don't know, I maybe just didn't look when I picked this one. It's very similar. All right, it gave you the derivative. So we have f prime is equal to x to the -3/7 times x plus 5. What does that tell me about the critical points? No. Aren't they the same thing? Yeah. So I didn't look real closely when I picked the problems. I probably noticed it when I was working them. But so we're not going to work that one out. The lecture notes have it worked out, but it is the exact same thing. And it wants to know, where's it increasing, where's it decreasing. You know, you're going to come up with the same stuff. Okay? All right. But now we got one that's different. All right. Now we've got the function. They didn't give us the derivative. H of x is equal to negative x cubed plus 4x squared. Find where it's increasing and decreasing. Identify the local and absolute extreme function, values, if any, saying where they occur. So write this down, and then I'll move down so we have room to work. Negative x cubed plus 4x squared. Oh, did I go right in the middle of the question? I think I did. That wasn't good. Go back up. All right, I think here is where I went. Okay. All right, so we had, what was it? H of x. H of x is equal to negative x cubed plus 4x squared. So you want to find h prime of x, which is what? Okay, then we're going to take that and set it equal to 0. I would factor out negative x. Bless you. No, I can factor out negative x. Change the sign. But good try. It wouldn't really matter. I just took that out because I know this is going to 0 anyway. Just get rid of him. And then I didn't have the negative 3x squared. So what does that give me for that one? X is 0. And for this one, 3x is 8. X is 8/3. What are these two guys? Critical numbers. Okay. So let's do our little chart. So we have a line, 0, x equals 0, x equals 8/3, which is, 2 2/3, somewhere around there. Define the intervals. Is it asking for intervals? Yes, it is. Okay, so we got that. Then we got to come up with some test points. You can pick whatever you want. And one of the big mistakes people make when they're doing these is they plug them in the wrong place. So if you write down here f prime of, that should remind you that you're plugging into the first derivative. That should make that happen. Okay, so you do that and come up with the signs, and let's see what you get. And remember, here was, that's the first derivative. Negative 3x squared plus 8x. What do we get for negative 1? Is it negative? All right. And do they alternate after that, or are we still? Okay. Did you say positive there?
Yeah, I got positive.
For this one?
On the outside, too, on the other side. I mean, no.
Okay, if I plugged in, I got negative. Did anybody else get negative? Okay. Oh, well, Barton got it. Okay.
I didn't get that. If you put -1 into it, it's gonna be -3 and try 8.
Are you plugging it in here?
Yeah.
So -3 times -1 squared plus 8
Oh
times
wait, no, I was doing it at the time.
the first one. Well, you mean the original? You were putting it in the original?
No, the derivative.
Well, that is the derivative.
Yeah, I was putting the 1 below.
It should still work. Okay, let's see. -1 times 3 times -1 minus 8. So that's 1 times -11. You're confused? Did that not?
No, it said it in my calculator.
Uh-huh. It works in either one. Oh yeah, you don't do that. That's the original. But he said he did it in this one.
So I put it in my calculator and had negative, but I wrote the constant in the wrong place.
It doesn't work well for you. Mm-mm. Yeah. There were some of you on the test, and I should, oh, I don't need that. I need this little guy here. So, what does this look like now? Here, and like that, because positive to negative, negative to positive. So where's our min? Right here, and this is our max. So we got a lot of information there. Let's go back up and see if we have everything that they asked us to find, because it's a lot of stuff. Okay, where is it increasing? So you've got your work in front of you, mine's down there. Where is it increasing? 0 to 8/3. Okay. Where is it decreasing? -infinity to 0? No, am I on the wrong one? Or is that the right one? Okay. And from 8/3 to infinity? And I guess there was a thing to choose here, just A, whatever. Okay. Absolute, okay, so you had to choose something here. Absolute and local max are both 0 and occur at. There is no absolute max. Absolute and local max are both blah, blah, blah. What do you think we have? What do you think? What I would do? Put it in the calculator. Yeah. You can do some testing. We're really not there yet, but I would put that original in there because it's probably, what is this, cubic? Yeah, put the original in. No, that's what I would put in, not the derivative. And see a picture, and what do you, because that's what they're asking you. Where is there an absolute max or min? And this negative x cubed, here's what regular x cubed looks like, but this one's upside down. So it should be something like that. Do you get something like that? Might be spread out a little bit. Does somebody have it? It's got more things in it because of this x squared. Yeah, but can you tell by the graph that it's not stopping? It's going on. So it does not have an absolute max. Do what? Right. Right. Or if you had a quadratic, would that have an absolute max or min? It would have an absolute lowest point. But when you have curves like this, you know, and you might have something that looked like that, and that would have an absolute max. But this one, if you put it in, you should be able to see. Okay, so is no absolute max. The local max is, well, we don't know if this is the right number. How would we find out? Here's where we said there was a max. Where do we need to plug that 8/3 in? In the original. So if I took 8/3 and put it in, what was our original, negative x cubed? And if you did that on your calculator, you're going to get a decimal. I don't know if it will convert back. You could do it by hand and get the right thing. Yes?
Every time I put that in the calculator, I get a positive, not a negative.
We're back on that.
I don't know what I'm doing
On
wrong.
which one?
The 8/3, I put a positive 3 and negative 3 cubed, or 3.
Oh, for this one,
Yeah.
testing this?
Yeah, I don't know what I'm doing wrong, but.
Okay, I put in a positive 3, so I had negative 3, parentheses, 3 squared.
Which, or 3 cubed.
No, it's 3 squared, because you're plugging it into the first derivative.
Oh, I'm plugging
You're
it in.
plugging it in the original.
Oh, I'm plugging it wrong.
Yeah. So your math wasn't wrong, you were just doing it in the wrong place. When I wrote it, yes, because I'm trying to find the original. Where is this max in the original? Okay? When we're plugging in to get these, we're plugging in the first derivative. And that's why I write it f prime of. Okay? So, were you able to get 256 over 27? Okay. And did it convert on the calculator? Okay, perfect. So, here. Yes. So this is the y value, and it occurs at x equals 8/3. Okay? And then this part is about the min. What are our choices, and what do we want? Is there an absolute min? You put that in your calculator. Is there an absolute lowest point? There was? Is that a local min? But is there an absolute? Let me borrow somebody that's got it in the, you got it? Okay. Sorry, I was gonna get yours. Okay, it's in the graph right there. All right, guys, this picture won't show up on the video because we're not recording what's on the screen. But, okay, so what's happening over here? It's going on forever. What's happening over here? Going down forever. So there is no absolute max or absolute min. If I changed the y max and went up some, I don't know how far, but let's see that. Okay, so when you look at that, here's a local max, and where does that occur? Second calc max, da-da-da-da-da. Where does it occur? 2 2/3, which is the 8/3, and here, this thing is probably, what, 256 over 27? So that's the max. Here's the local min, which occurs at x equals 0, and what's the y value? 0. Okay? So you can check yourself by using the original. All this stuff that was developed was way back before there were calculators, and you had to determine some things by using the derivatives only. You know, you didn't have something to throw it in and see that. Okay? But does that make sense? So our answer was here. Oh, yeah, you'd like to see, wouldn't you? So it was this one. Okay?
Yep. 0, did you plug that 0?
Yeah, if you plug the 0 in the original. Right. What was that? Is this that? Yeah. So if you plug 0 in, what are you going to get, Jeremy? 0. Okay.
So that's how you determine the local max or local min?
The y values.
Just
Yeah.
plug them into the original.
Right. All right. Okay. How about number 4? You try that. Because we've done a couple of them now. Let's try it and see what you get. Here's the original. I'll write it bigger here. T to the 4th minus 2/3 t to the 6th. And it wants to know where it's increasing, where it's decreasing, what are the max and the mins, and where do they occur. And we're not to do this in our calculator. That's not where the work's going to come from. The work's going to come from doing the derivatives. So there's that work for getting the critical points. Okay? And you just want to be careful. You want to brush up on your algebra and your factoring. That's important.
Could you do it? I just took T cubed out. Could you do it like that, or would you do it?
Well, you would still have the difference of 2 squares, because you would have had, you took out t cubed and you still had 4 minus 4t squared. So that's 2, and then you would have 2 minus 2t and 2 plus 2t, and you're going to get the same answer, Keith, so that's fine. You just made yourself a little bit more work, you know, at the final, but it's not a bad thing. It's okay. You want to try to always factor out the biggest thing you can factor out, but you'll just end up doing a little bit of work down the line. Okay. So,
But you plug your test point into the derivative.
yes, yes. I would define the intervals. Do you have 4 intervals? Because you have 3 points. You should have these intervals. I should hide the testing. You are doing H prime of those test points. And remember, you're just really looking for the sign. So if you could do it without even plugging it in, if you could just look and say, oh, well, I'm going to multiply negative times negative, blah, 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 you could do it that way because nobody cares what the value of the number is. It's about the sign. I'm going to put that up there. I don't know if you can read that green. That's really light. I don't know why I used that. I just kind of go till I see what the sign is, and I probably put some there.
I just did. I did like you did negative 0.5, but if it's positive 0.5, it's just not.
Right, right.
Okay.
Which one?
No, it's-
Oh, okay.
I look at it and I think I'm plugging in -2 for the first one, and I can do that without, like, I can realize it's positive. But if we just plug in -0.5 in, why is that one?
Okay, well, this is gonna be, you know, you're gonna be cubing this, and it's gonna be negative. And so when you multiply it by 4, you'll have a negative something there, but you're gonna end up with, is this to the 5th or to
No,
the?
what I'm saying
Oh,
is
what?
if you've got the same amount of sign changes in both of those, why is one negative and one? You don't understand what I'm thinking?
I'm trying. I'm
No,
trying.
no,
No, no. Because it's such a small value, and you've got a subtraction in here.
So I just need to actually plug it in.
Yeah, this became negative 32.
Yeah.
Multiplied that, and it was positive, and it was big enough to counteract this. Might not be the case here. It's not the case. So sometimes you have to do that. Okay. All right. So did we get those test values and all of that? And you did this and this and this. Now the question is going to ask you, where do those occur? They occur at x equals 1 and -1, we have max, and a min at x equals 0, then it wants to know the y values. So where are you going to plug these three numbers in? The very beginning. You're going to put those in the original. The max occurs at x equals -1, x equals 1. That means you have to find f of those numbers, or whatever the function's called. I don't remember. I think it's h. Shouldn't be an f. And I got those values. Now, if you're using the calculator to plug them in, you're going to get decimals instead of fractions, and you will want to be able to convert because it's not wanting decimal answers. Questions on that one?
Initial is not,
About?
you hit second table, find where your values and bring that.
If you're using the calculator.
As long as you plug it into Y1,
Mhm. Mm-hmm. Yep.
take second table.
Yeah. Or you could just do second calc value and put in your x value and get it like that. Yeah, for sure. But again, this whole process was designed before those existed. So it wasn't like you could go do that. You know, I know that's hard to believe they didn't exist, but they didn't. All right, so back here, you would fill in the right answers. The absolute and local max are both 1/3, and they occur at x equals -1, 1. That would be that answer. There is no absolute min. The local min is 0 and occurs at x equals 0. This is when I would be using the calculator. I would throw it in there, the original, and see that. The max, 1/3. They're both 1/3, and they occur at -1 and 1. Down here, we knew there was a max from our picture, and then we plugged those into the original. And we got 1/3 for both of them. 0 is the min. These are both maxes. Well, if you, yeah, it said there is no absolute min, and if you had put the original in, it's a local min. It's a local min. All right, so we're good on that one? Okay. Sort of? Okay. All right, this is a good one. And by good, I mean fun. All right, what do we have here that we're going to have to take the derivative of? Quotient, okay? X squared minus 8 over x minus 3. That's our original f of x. So you're going to go ahead and take the derivative, set it equal to 0, and see what we get.
Could you, like, hypothetically change that to -1 and change it to,
Change what to -1?
like, parentheses around to -1 and change it to, like,
Where do we have -1?
like the x minus 3, with parentheses around it, put a positive or a -1 on the top, and move it from the bottom to the top, and use it as like a channel, like the whole.
But you're arbitrarily creating things. Are you saying you want to do this? Well, you know, that might work. Okay, so you're saying you would have x squared minus 8 times x minus 3 to the -1?
Yeah.
Yeah. You'd have a product rule. Yeah, I don't know that it's a whole lot easier. But yeah, you could do that. I wasn't getting what you were saying, but it finally clicked.
I just get a mix.
Yeah. Yes. Yep. But you can't do that because it's not a factor, it's not multiplied, you've got this in here. That keeps you from being able to do that. If it were something times something and then you had that on the bottom, you could cancel. But because this is a subtraction, you can't. Okay? It would have been a good idea if that were the case. Okay, so did we get this? Eventually, and we've got to set that equal to 0. Or questions? Let me go back up. Okay, I had this, and this is, you see it?
I was confused about going from there
To here or here?
yeah.
Okay, just combine some like terms. And this one's important to note something. When you set this equal to 0, what do you know about this right here? It what? Does go away, but what else do we know as far as the original? There's a discontinuity at x equals 3. It's on the bottom of this fraction. That's going to tell us it's discontinuous there. So besides being, it is a critical number, what are our critical numbers? They're actually 4 and 2 and 3. 3's just going to, it's going to be discontinuous. There's going to be a hole there in the original because it's on the bottom of this. But when we're solving this, it does go away. And so you get x equals 4, x equals 2, x equals 3. Because critical numbers are where the first derivative is equal to 0 or the first derivative does not exist. And that's that case. So where it's equal to 0 or where it doesn't exist. So here's your critical numbers. Okay? And then you make your chart. And we already know there's a break here. We just know there's going to be a break there. And I did those, I did them up here in different colors as far as this because I showed increasing, decreasing, decreasing, increasing, and that there's a break there. You can run your tests on that. You do need to be able to do that, but we've kind of, yes ma'am. Because it was discontinuous there. That tells you if it's on the bottom of the fraction, when you do the derivative doesn't exist there, that means there's a break.
So you plug your numbers into F prime or the various beginning?
Your test points you plug into F prime, but to get where the max occurs, you plug in the original. Okay? So that's the difference, and you want to get in the habit of writing F prime to test. In the next section, we're going to be testing some second derivative, and you'll want to write F double prime. Write what you're testing so that you don't get messed up there. And I just started doing all this work, then we'll go back up and we'll see what they want us to answer. But this is all the good stuff. And once you've done this, that curve sketching form is going to make sense, because that's what we're getting to. We're getting to where you can take all this information and get an idea of what the original looks like, with we add some other information to it. All right. Anybody have questions on this one? Are we good? If we go back up here, it asked where was the local max. It was at x equals 2, and the local min was at x equals 4. It wanted to know absolute values. There weren't any, because if you put it in, you'll see that. Where is it increasing and decreasing? It was multiple choice, but we already have that picture. Where is this thing increasing? From what to what? 2. 4 to infinity. So it's increasing those two. It's decreasing from 2 to 3, and also from 3 to 4. It's a break at 3. Okay, so you'll be filling in that word. That should be good. All right. Any other questions on that one? Okay. Let's look at, are you still writing, Lee? I think
The only thing I'm having trouble
let me
understanding
go back.
is, I think it's really simple here, but like, so you would say it's increasing at the interval of negative infinity to 2.
Mm-hmm. And here.
All right.
And it's increasing because you're going from
And so you would
positive
plug,
up
you plug that 2
into the original.
Why not the 4?
We did.
No,
We
for the
plugged
max?
that in. Not for the max.
No, well, see, I'm looking at it, and it's like, I think, okay, I'm looking for the max, so I plug in where it's increasing. How do I know I don't
You're
plug?
increasing, you're plugging in. Where did it change? Where did it go from increase, and then decrease? It makes a picture of a max.
I got it.
Here it's decrease, decrease. At 4 we change and we start increasing. That's a min.
All right.
Okay? All right. So how are we? Are we, bless you. There's a couple more, but do you feel pretty comfortable in doing these? Okay? You're good? Okay.